Hello, today we're going to go over an iOS client that connects to a backend running in Windows Azure websites. This is part 2 in a video series going over connecting mobile clients to backends hosted by Windows Azure websites. In part 1, we created a new Windows Azure website, pulled down the PHP code from GitHub for the site, configured it, and pushed it out to Windows Azure websites. If you'd prefer a written down walkthrough of this tutorial, you can go to the bit.ly link shown here. As a reminder, this site functions as a URL shortener. Here you can see the home page of the site when we go to it, and when we click on this link we can see the URLs that have already been shortened. The mobile clients will allow you to view the same information, that is the shortened URLs, in addition to adding new ones via the client. Let's start by pulling the iOS app source code down from GitHub. The sample can be found in the Windows Azure -samples organization. And if we go down, we should be seeing a URL shortener iOS client. All the code is more or less ready to go. All we're going to have to do once we pull it down is connect it to the site we set up in the previous video. Let's go ahead and grab the get URL and clone that locally. Now that the repo has been cloned locally, we can go ahead and navigate into it and open up the Xcode project. Now our project should compile fine as it is right now, and it does. However, if we run it, it's really not going to do what we want it to do. So there we go, we've got an error. And the reason is that the code is not currently configured to go against our website. It's configured to go against a URL that doesn't really work. Let's take a look at fixing that next. So to configure our code, let's first go back to the browser and go back to the website. As we can see here, URL shortener test is the custom part of our site's URL that we're going to need to add to our app. So now that we've got that copied, let's go back to our source code and open up the project navigator. And we're going to open the constant.m class, and as you can see here, this your subdomain, that's what needs to be replaced. Everything else is set to go up against Azure websites, and even the API calls are already set. We just need to replace that subdomain. Let's go ahead and rebuild. It built successfully, and now we're going to run the app and actually walk through some of the functionality. So let's go ahead and run our app. Okay, so now after a few seconds we've pulled back the URLs from our site, and we can see that these are the shortened URLs. If we switch back over to the website, we'll see that these do line up with what we've got here. So the shortened URL for MS goes to Microsoft.com. If we click on this URL, we'll get the details and see that the full URL is www.microsoft.com. The short URL is our website /ms. And if we click on this Go to URL button, we can see that it's going to display the URL. Again, if you don't remember from the last video, instead of actually having it redirect to the URL, for now we're just having this website echo it out for testing purposes. The source code of the website actually has lines commented out. You could just flip them and then it would take you to the site, as opposed to just showing the full URL. So now that we've shown that, let's go back to our app, return to the list. Let's go ahead and add a new URL. So we're just going to shorten the URL for Xbox. We've entered the URL slug and the full URL. Let's go ahead and save that. We're hitting a breakpoint again. Okay, so now our URL has been added, and if we click on this, we get the same information that we had before. That's really all the functionality this app has right now. It's just a simple demonstration of connecting our iOS app to a backend running in Windows Azure websites. Let's take a little bit deeper look next at some of that code that actually handles those communications between our app and Windows Azure. Let's return to Xcode and open viewcontroller.m. Viewcontroller corresponds to this table view you see when the app first loads. This table view displays one shortened URL in each of the table view cells. Let's start by looking at the viewDidLoad method. This method right here creates a background queue and tells it to fetch the data at this kgetAllURL. When that's done, it calls the fetchData method on this class. Now, kgetAllURL is defined in constant.m and merely points to the endpoint of our web service, which returns all of our shortened URLs. Let's go ahead and go back to viewController.m and let's look at the fetchData method. Right here, the fetchData method is called and it's passed in with the data that was returned by hitting that web service. The first thing we're doing is using JSON serialization, because the web service returns its data in JSON format, into a dictionary. After that, we check to see what the status is. If the status is a success, we create another NS dictionary and called URLs and set the data that was in the JSON object for URLs to be that data. When that's done, we get a reference to the app delegate and set an app delegate URLs property to be that URLs that we got back from our web service. Afterwards, we call reload data on the table view. If there was an issue, instead, we'll show an alert view to let the user know there was a problem. Let's now go down to the bottom of viewController.m and look at the table view delegate methods. As you can see, we're just saying there's one section. When it comes to get the number of rows in that section, however, we're pulling out a reference to the app delegate and getting the count of rows or objects in the URLs dictionary. Then, lastly, when the delegate's called to say what belongs in this row, we're getting again the reference to the app delegate and pulling the key text out from that. Now, let's go ahead and open up the URL details view controller. This view controller corresponds to what you see when you go to an actual already created shortened URL, and it's also the same thing as what you'll see here. We're just showing or hiding fields depending on what we're doing. Now, when you tap Save URL, essentially what happens is we call back to a delegate for this class and call didAddURL with slug on it. Now, the view controller we just looked at is actually the delegate that this is corresponding to, so this didAddURL with slug is actually contained within viewController.m. Let's go back to viewController.m and take a look at it. Let's go ahead and look at what happens in didAddURL with slug. The first thing we're doing is creating an NS mutable URL request. We're using a mutable URL request as opposed to just a URL request because we're changing some of the properties on that request after its creation. As you can see here, we're setting the HTTP method to be post, and we're setting the content type header to be application JSON because we're sending JSON data across. Then we create our dictionary with JSON data in it. We use NSJSON serialization to serialize that into an NSData object. We set the request HTTP body to be that JSON data. We create a URL connection with our request and set the delegate to be self so that any of the delegate methods called an NSURL connection are called on viewController. And then lastly, here you can see that we're adding the URL to our app delegate object and calling reload data on the table view. As you can see in this example, we're actually adding it before we hear back from the server. The assumption would be that everything goes fine, and then maybe we would have to manually show the user that there was an error and remove it down the road. Let's look at some of the NSURL connection delegate methods that are called when this connection happens. First is did receive response. Nothing really interesting is happening here. We're just initializing the receive data object. When we did receive data, again, nothing terribly interesting here. We're just adding that data to the receive data. There's a connection with error. We're logging that. We're really not informing the user here, and this is really where you might want to manually pull that URL back out of the app delegate object and actually present something to the user. Lastly, in connection did finish loading, essentially all we're really doing is pulling out the status and then displaying an alert view depending on what that status is. Here what you may do is if you wanted to not put the URL in that table view until it was for sure added, you might actually add it to the URL delegate and tell it to reload the table view here. Instead, all we're doing in this case is showing an alert view. That's really all there is to the interaction between this app and Windows Azure websites right now. As you can see, everything done here is pretty standard NS URL requests and connections, or background queue. There's nothing too fancy or too difficult about talking to our Windows Azure website backend. In the next video, we'll take a look at how to connect an Android application to the same backend. Later, we'll have more videos to discuss how to do a little bit more advanced things with our iOS client connected to Windows Azure websites. I hope this has been informative. Thank you for watching.